Hello, everyone. How are we doing? Are we all coffeeed up? Had breakfast, had coffee, ready for the next 45 minutes while we will be talking about Terraform. I'm Natalie Godec. I'm a senior cloud architect at a small boutique Google Cloud partner called Zencore. We do engineering. We go to our clients and implement complex systems, solve complex technical problems for them, do everything from the design to seeing the data, figuring out what to do with it, to implementation. I am an architect, so I design systems, but I also write loads of Terraform and YAML files and stuff like that. I do everything around infra, data, and security, and this QR code will take you to my socials. If you want to stay connected, you can scan it and connect with me. I'm also a photographer, and you can find on the QR code my Instagram. So I've been doing this DevOpsy platformy engineering thing for quite a few years now. There's a couple of ideas that come again and again in conversations about how to configure your platforms, how to configure your systems. One of them is, if you can, it doesn't really mean that you should. And one of the main ideas in the DevOps and platform engineering world is automate everything. And that one is closely followed by abstract as much as you can. You know, we started with physical servers and physical infrastructure where you had to order your server and wait 3 months for it to arrive and be configured. Then we started doing virtual machines and having an abstraction layer on top of the physical infrastructure. We no longer had to think about what goes on in the physical world. We started doing configuration as code in order to abstract what and where the virtual machines are. We then had software-defined everything. We're abstracting away the networks, the routers, the firewalls, all of that. Then came containers, and adding another layer of abstraction on top of virtualization. And now we have cloud, which hides away the whole infrastructure in general, and we don't even need to think that there is a physical server somewhere under the hood. And then we do infrastructure as code, and we do abstraction of the cloud APIs, abstraction of the cloud resources, figuring out what we describe, what we want to have in our infra, but we don't really think what goes on under the hood as well. Then we do CI/CD for Terraform to not even think how Terraform works. Then we do pipelines to take in the code, the input, and translate it into something that looks like Terraform variables so that our developers don't need to think about Terraform code. And at the end goal is to have an ability to say to our developers, hey, you can deploy all of your infra with 3 lines of YAML. Great. But where do you draw the line in those layers and layers and layers and layers of abstraction and automation? Is it here? This is one of my favorite things about Terraform syntaxes, this little 3 dots. I call it black magic. It gives me the comfort in saying, I have no idea how this works, because the code itself suggests that it doesn't have an idea how it works. It does work. Or is this where you draw the line? 2,000 resources in the same state. Imagine debugging something when you have 2,000 resources in the same Terraform state and one of them went wrong, and you have all of those layers of pipelines and automation and YAML files. How do you find what went wrong? Terraform is something that we need to remember. Terraform is a configuration language. So the idea is that we describe the desired end state of the infrastructure. We don't say, please deploy me a virtual machine and attach 8 gig of memory to it. No, we say, I want a VM with 8 gig of memory. And it's for the system to figure out whether that VM already exists. Does it have 8 gig of memory? Does it need to be created? What we do is we describe the end goal. We don't define a procedure. And that's a fundamental difference between, for example, software engineering, where we define a flow, and configuration languages, which are also considered sometimes software, but you declare things. So it's declarative. And that's really, really important to remember. If you don't remember it, or you're just starting out with Terraform, or you are a software developer who is trying to write Terraform, no shade, no shame, but it's important to remember that it's a declarative language. If you don't know the best practices, it's really easy to get into like loops and dependencies. You can get state drifts, and that's a big issue with people who are maybe trying to define their infra in configuration languages. and they get state drifts because they haven't thought about it being an entire platform and everything managed automatically. You get inconsistency, which is my personal pet peeve, inconsistencies between infrastructure and between different states in the infrastructure. You get security holes, because if you have those 2,000 resources in the same state, someone will have forgotten to enable encryption, and you get security holes. And also, if you are building a platform and you're giving your Terraform to your developers to deploy their own infrastructure, if it's too complex to understand, if it's too complex to configure, they will go away and do their own thing in their own corner. They will not follow your standards, they will not follow your ideas of implementation and your company's standards, for example. We call it off-the-road implementations, and you get all sorts of nasty things in there. But it's really easy to fall into those issues if you don't know the golden standards. It's easy to end up having overly complex configurations. Let's say you're writing a Terraform module and you want to figure out a use case, and then someone else comes and says, I need this other thing. So you add it to your module, and you want to abstract some other team's requirements, and you add that into the module, and then someone else comes and has an edge case, and you add that to the module, and you end up with having a kitchen sink in your same Terraform module, loads of transformations and conditions everywhere. Nobody understands how to maintain it, and remember, you've written it, but then you will be gone, and someone else will need to maintain it. If it has a kitchen sink and every use case in the same place, and loads of different transformations and conditions, how will anyone be able to maintain it? You always need to think what will happen in a few years after you're gone. Some examples of that is this really necessary? Like, it's correct syntaxes, but is it really necessary to have 1, 2, 3, 4 loops in Terraform, in data sources? Come on. And this doesn't even show the locals of this module, which has another four loops. Is it necessary, or could we have maybe thought about it differently, and could we have maybe written it in a simpler manner that doesn't really transform the entire input into something entirely different? And when you try to debug it, I stumbled upon this because I needed to debug something. Could I debug it? Because this is just, you can't understand it. Another example, someone was defining a subnets module, and this is how they define the variables. The subnets is a list of maps for the subnets, and here there's one, but you can have 13 of them. And the secondary IP ranges for the subnets is a different variable, and you define it as a map where the key is the name of a subnet that you defined in the first variable. You could have it like this. The secondary IP ranges are within the definition of the subnet. Why? Why did you do that way? What was going on? What's wrong with having the secondary ranges? What even made you think that the secondary IP ranges needs to be another map where the key needs to match what you did in the first variable? And what if you define the subnet names dynamically, which is what you should do in order to have consistency? You should have your region and your environment as inputs, and then define the name generated out of like name of the subnet, region, environment. Why would you do it differently? Well, in the module, it looked like this. Again, why? Why? No, don't do this. Why would you do this if you can have this? A dynamic range that takes the secondary IP ranges out of the variable and generates them. Done. I think what happened is this was written before the dynamic IP ranges were, dynamic blocks in Terraform were a thing. But that was introduced 4 years ago. Why hasn't anyone looked at that module in that company before and said, hey, this doesn't look good, let's rewrite it into something much simpler and have a much easier situation in our modules, in our Terraform. Everyone uses the subnet modules. Why would you make it complicated? Another thing about Terraform being a declarative configuration language is procedural flows are not really part of the logic. Yes, you have the for loops, you have the dependencies, you have the loads of functions and options and operators and ifs, all of those things. But at the end, it's a configuration language is declarative. And also you can have things like local execs. Everyone hates them, everyone has them at the same time. And there are also resources that don't necessarily lend themselves really well into being declarative. One example of those is AWS VPC peering. In AWS, you need to declare the provider, initialize the provider with the region and the account. But for the VPC peering, you need to instantiate it in one account, then go to the other account, confirm it, wait for AWS to do its thing, and then do something else. It's complex to do. It's a procedural thing. You need to wait for something to happen. Another example is Kubernetes on the cloud. There are so many things happening for a Kubernetes cluster to exist. Also, depending on the provider that you use, some abstract more than others. It's complex, it's difficult. If you need to deploy some things, wait for them. I've seen null resources with timeouts and sleep mechanisms to wait for the first resource to be deployed. Then someone needs to run some Ansible on the node pools. And if a team comes to you and says, hey, can I have a Kubernetes cluster? And you say, let me put it on my roadmap. I need to think about it. I need to copy some secrets from Vault locally and import them into Kubernetes and then manually finish the applying. No. What you can do with Kubernetes is use community modules or official modules from cloud providers. Why? Because someone has already thought about it. There's a lot of people who have looked at the code. There might be little sleep null resources here and there, but it's been tested over and over and over and over again. And if you have the possibility to use the community modules or use the official provider modules, please do that. Some companies can't do that because of internal policies, compliance, and so on, but you can still copy the community module and make your local modifications, maybe add some necessary labels or something like that, security policies. But you can use, this is a community module for EKS, for AWS, and there is a number of official GKE Kubernetes modules for Google Cloud. So if you can use them, please do. That will make your life a lot easier. There's, this is a screenshot of the first, however many, 20 parameters, but there's 150 of them for Kubernetes. So imagine writing that yourself. You don't necessarily want or should do that. And another thing that people very often fall into, because Terraform can manage however many resources you want, of course. And so people end up with all-in-one states. It's really easy to say, okay, hey, I'm going to deploy all of my databases, all of my database instances in the same place. And that's great if you have 3. What if you have 300? And all of them, it's not just a database instance. There's a whole load of resources that need to come with it. And all of them are in the same state. Someone in those 300 databases in 10 environments will forget to enable encryption. And you will end up with a security hole. Or something will go wrong. Someone will break the module, and now you have 300 databases that are broken, and you need to debug it over and over again. Or if you work in the security team, it's really easy and nice, actually, to say, hey, I'm going to manage all of my IAM in the same place. All of my permissions, roles, and assignments are going to be in the same place. Cool, nice, secure. A developer comes in, looks at that, says, I'm going to go into my own corner, and I'm going to script in my CI/CD the assignment of the IAM roles. And now you don't know what's going on. And it's not managed in Terraform. And it's not nice. And nobody's going to use it because it's too complicated. And of course, if you have to do a targeted deployment, not in a situation where you're like, OK, I'm debugging something. I need to target apply, fine. But if you know that without the target, your Terraform apply will fail, you are doing something wrong. You need to fix it. You need to fix the core issue. And maybe you'll say, oh, but my environment is so complex. Make it simpler. If you have to do targeted deployments, something is wrong. And TerraGrant is an abstraction layer on top of Terraform, of course, because we don't have enough abstraction layers. This is technically correct. You're doing targets for each module. That way you can say which environment deploys which modules. But it's a target. It serves the purpose, but So, OK, fine. We've learned what are the bad things to do, what not to do, but what it is that we should do, and what it is that the industry sort of is gravitating to, because the industry is where like loads of people are working on these things and loads of people are coming up with the same ideas, and then we kind of are converging into some sorts of golden standards. Well, the first thing that I would suggest you do is define a single point of deployment. What is a single point of deployment? It is all of the resources that you deploy together and manage together. For example, it could be all of the resources that are serving a specific microservice. Like you have an app and it needs some infrastructure. All of that infrastructure might be a single point of deployment. Or it might be a group of resources needed by a single team. This isn't usually the case for like developers and application teams, but it is the case for analysts, or maybe your FinOps want to do some sort of thing with cloud, or something like that. Or maybe it's standalone, very complex infrastructure pieces. Like Kubernetes, it's big, it's fat, it's complicated, it's complex. So I personally like to have these fat pieces of infrastructure in a separate point of deployment, not together with the bootstrapping of the whole environment and databases and IAM and all of those things, but separately. Examples would be, for example, you have a client profiles service. You need an RDS instance, so database on Amazon. You need a parameter group, you need security groups to secure it. You need the rules, you need to configure logs, you need to configure alarms and monitoring, SNS topics for the alarms, IAM roles and policies for the accesses to the database, and some KMS key, because you want to encrypt the database, or you want to encrypt the SNS topics. All of the resources that this client profile service needs. This actually grants you the idea as well to create something called service modules, which is a Terraform module that uses other resource modules, but it's like a chunk of infra that many different teams and many different apps might need in the same format. It's likely that you don't have just one service that needs a database, IAM groups, and SNS topics. Maybe you have more. It's likely that you have more. So by creating this service module, you will have a reusable piece of code with nice and easy inputs, which I will go into, which you can give then to the developers and say, hey, this is how you define it, and you will have all of your infra. And you don't need to redefine Terraform itself over and over again. An example of a group of resources needed by a single team would be like data analysts or the AI team. Maybe they want to do something with Vertex AI on GCP. So they will need a project, they will need a VPC because Vertex needs instances. They will need to be protected because they are analysts, they are data scientists, they have no idea how to secure infrastructure, so you need to secure it for them. They need some BigQuery datasets to work with data, IAM roles, storage buckets, some other stuff. Cloud Run if they want to do a web app to expose the results of their models, to run their models. Cloud Run is a serverless container runtime, so you don't necessarily need a Kubernetes cluster just for one team. They might just have some containers that they throw into the cloud. And Vertex AI. So you have an AI team, they have a new project, they want to build a new model that develops. Yesterday we were at dinner, we were talking about admission rates and statistics for a hospital. They want to develop that model. They will have a full working environment by just deploying this one thing. And they are quite independent from the rest of your infrastructure. And another example of like standalone complex stuff, technologies that I personally like to separate from the rest. I mentioned Kubernetes. There is also Composer on GCP, Airflow on GCP, which is kind of clunky. It's not that clunky in terms of number of resources that you deploy, but it takes an hour to deploy. Do I want someone who is creating a bucket that takes 3 seconds to create to be dependent on some changes in the Airflow cluster, which take an hour to deploy? No, I want to separate them. Another example of that is OpenSearch, so Elasticsearch on AWS. You need the cluster, security groups, rules, CloudWatch, logs, alarms, topics for that, KMS keys, configurations, even lambdas to manage the configuration of OpenSearch. So that's a lot of things to manage, and like if you are bundling that together with your EKS cluster and with RDS instances, like your state just grows out of proportion. And maybe it makes sense, but maybe it doesn't make sense. Maybe it's easier to separate it into a standalone point of deployment. And you also don't change these things very often, which leads me to some of the criteria of how you define these points of deployment. This needs to be a sort of an independent system, an independent set of resources. They will change together, they will evolve together, like all of those resources for the OpenSearch cluster, they will change together and evolve together, but be independent of the rest. Yes, granted, OpenSearch needs a network, but the changes in the network and the changes in OpenSearch are independent from each other. They don't conflict between each other, there are no dependency issues, and they are independent of the whole of your infrastructure. One typical pattern of doing is like you have, let's take GCP, right? You have the org resources, your hierarchy, your org policies, your security policies, your audit logging, which needs to encompass the whole organization, your workload identity federation for the identity of your pipelines. All of those things are centrally managed, and you only need to deploy them once, so maybe change it every now and again. Then you have the compute groups per environment, like dev, prod, staging, whatever, compute, and your data. So that separation kind of deals nicely with this separation of single points of deployment. Then you manage your compute for dev in one place, your data for prod in another place. It's different states, they're stored nicely, they deploy relatively nicely, and you have a lesser chance of conflicts between them. Another thing that I would like to mention is how to make your modules work nicely in that sort of setting. So especially if you are building a platform where you need to serve multiple teams, and they are developers and analysts, they don't necessarily want to know how to write Terraform, and you also don't want to have to adapt to each use case of each team every time. So how do you make the modules really flexible if you're writing them on your own? The community ones will already be flexible. So you define the variables in the module with, like regular variables, okay, fine. With defaults where necessary. I like making defaults of the variables in the module abstract, not connected to your business logic. But if you are writing it for like your own company and you know that there are some specifically security defaults that you want to set, you can do that in the module as well. Then in your point of deployment in the environment, you define each resource inputs as an object. So these, if you look at these variables that we have, org ID, name, project ID, folder ID, and services, I define them all in an object in a single variable called project. This way, I'm managing it all in a nice little chunk, and I'm also defining the things that are not required as optional. I love this feature. When it came out and was in like alpha testing, do not use this in production, I was already using it because I was sure that it's going to stay. This is such a crucial piece of functionality. Your elements of the object are optional, and you can redefine. So if you don't define a default, it will default to null, but you can redefine the default to whatever you need in this case. What if you need more than one? Like what if you are defining buckets, storage buckets, or Bastion hosts? And there might be a need for one, or there might be a need for 20. In that case, I like doing it in a map of objects, and your key will be the name of the resource. And then you pass it into the module in some sort of way. And you default it to an empty map. That way, if someone needs a Bastion and they come to the environment and they define inputs for a Bastion, there will be a Bastion. If you need 7 Bastions in different regions, you define 7 elements of this map, and you'll have 7 Bastions. That way, it's really nice because you no longer need to think what will happen in an environment. It all just depends on inputs. And then you define the module, initiate the module with a for each. And you're done. People can just come in and just change the variables. So when I write Terraform for foundations for my clients, when they need to change things, the only file they will ever need to change is the TFRs. because all of the module initiations are defined in such an abstract way that allows them to like redeploy multiple environments, change like one variable environment to maybe a region also changes. Boom, they have an entire thing redeployable because everything is structured, everything is structured in the same way, and everything is readable. Which then leads me into design patterns, guidelines, and I can never pronounce these words correctly. Guidelines and guardrails. What are those? I just mentioned one design pattern. Have your modules very flexible and have everything structured so that the environments don't need to change inside the code. So that's the design pattern. Those are easy to use, understandable modules that are clearly published, that are clearly documented. That anyone who looks at the modules that you already have and the environments you already have, if they need to add, I don't know, a Redshift module, they will be able to write that Redshift module in a way that is compatible with the rest of your infrastructure and with the rest of your Terraform. Now you have consistency everywhere. But you need to clearly document everything, obviously, and clearly publish the modules that you have, and give people access to work on the modules. If you are a centralized platform team and you manage the Terraform modules for the entire organization and you insist that everyone uses those modules, please make sure that everyone can read that repo and that people can open merge requests or pull requests if they need new functionality, without asking for permission first, because, oh my God. Guidelines would be clearly documented and communicated standards, specifically in security, that are not yet enforced. They are published. And they are integrated with CI/CD. And then the next step is guardrails. Those are enforced. Those are your compliance policies. Those are your org policies. AWS config is your policy. Things that say, for example, in a guideline, you say, you shall not open a public IP address on a compute instance, VM, EC2 instance. And then guardrail would be, oh, there's a public IP address, I'm going to delete it automatically. You can do that. There are tools to do that. But first, you need to do the guidelines, because if you start deleting resources without first telling people for months that you're going to start deleting them, people will be angry. And you don't want your developers to be angry. You want everyone to be happy, but your platform to be secure. So how do you do that? There are tools. I'm saying there are tools. Level 1, format and validation. I hope you're doing this in your CI/CD. It's really easy to do. You open the pull request, run format, run validation on it. Easy. Level 2 is Checkoff. It's an open source tool. It comes with a bunch of community-defined policies. You don't need to think. You can just integrate it into your CI/CD. Boom, it checks Terraform for security vulnerabilities. Terraform configuration, like someone is giving an admin role on the org to a service account. Maybe that's not great. You can also define custom policies. If you have some special security requirements, you can do that. Level above is Terraform compliance, I believe also open source, which is like OPA, but for Terraform. And there you can define things like if the IAM assignment is on a folder and the group and the member is not a group and the role is admin, deny. Or like if it's a group and the group is platform admins, allow. So you define more fine-grained contextual policies in terms of security and compliance that are specific to your organization. And then another very cool tool, InfoCost. I haven't used it in a couple of years. I don't know what state it is in now. But basically, it calculates the changes in the price. Like you're deploying a VM with 96 GPUs. It will tell you how much it will cost. So your wonderful AI people who are wanting to do super cool infrastructure for data science and need very beefy resources, they will at least be aware that it costs EA much. Also integratable in your CI/CD. This is GitHub. You just run it on a pull request, and you have all of that information. Visibility is often key to getting a platform into a state that everyone is happy with. And once you've done all that, you have happy messages from your analysts. This is from a data engineer. who was very happy with the way Terraform was now structured because they could do their own thing without having to talk to the platform team. And that was a big deal for me because they are data people. They don't know how to manage infrastructure. It's not their job. They are really good in their own domain, in dealing with data. I have no idea how to make sense of data. They do. And so me being able to hand Terraform over into their hands and have them not open up security holes everywhere or blow up the budget and be comfortable and confident in dealing with their own infrastructure, that was a big deal. And a big part of it was talking to them and figuring out what they needed. And something that I haven't mentioned as well is, like, if you need to abstract every use case in a module, maybe you don't. Do you really have an infinite number of possibilities that you need to cater to? Maybe not. Maybe you have to define 3 or 4. So in this case, for the data engineers and analysts, we defined like the offerings. One was an AI project, one was a data science project, one was a special permission, you have clearance from the government to deal with PII project. Those were the 3, and they had a set of resources that people could deploy as they needed and configure as they needed, but there isn't an infinite number. They can maybe say that, oh my God, I need to run Cloud Run, and I need a Kubernetes cluster, and I need it yesterday, but do they? Often they don't. Often you talk to them and you're like, oh, hey, you can use Composer for that. Oh, okay, cool. And they walk away, and they already have Composer. So often it's about like finding those points of deployment, but also finding the offering that you are willing to give to people as part of your platform. And the takeaway points would be, remember KISS. If you don't know what KISS is, Google it. It's my favorite engineering practice. Always ask why. Why does someone need a Kubernetes cluster? Why is one writing 5 for loops and 3 transformations in the same resource? Do they really need that? Why is your thing structured this way? Is your environment this complex? Why is it that complex? Can you simplify it? Always think about simplification. And always think about understandability. And that's a term that is often used by Anton Babenko, who is a fellow Ukrainian and a big AWS and Terraform and open source person, maintainer, hero, star, I don't know. He's very active in the community, and he has written and contributed to a lot of AWS Terraform modules. And he always talks about understandability. And it's so, so important. Your thing that you wrote needs to be understandable not only by you and your colleagues, but also by people who don't deal with infra and Terraform day to day, every day, 24/7. They don't live and breathe for loops in modules. They need to read it and be able to understand what's going on. And someone who comes 3 years after you, a little intern, also needs to be able to understand it, because you're gone, you're off, you will never look at it again, but someone else will, and they will need to maintain it. And on that, thank you very much. We will open for questions. And again, this is the QR code to my social media.
Thanks a lot, Natalie. Are there questions for Natalie?
Catchbox, I love those.
You'll get to throw the box. You'll get to catch the box over there.
Thank you, Natalie, for the talk. One question, what's your take on layering modules?
Don't layer too much. I think 2 is good. And if you have TerraGrant on top, that's okay. But the service modules that I mentioned, that's exactly that, right? You have the resource modules, like one that manages database instances, one that manages networks, one that manages IAM. And then you bundle all of them up in that modular way that I showed with like maps and everything in a service module, and you hand that into the hands of your developers, and they can now use it without having to write more Terraform. Yeah. But if you go 3 layers or above, you'll get lost. Everyone will get lost.
Thank you.
Thank you. More questions? Back there? Oh.
Sorry, thanks for talk. Is it? What is your take on Open Tofu? Did you switch your people recommend people to switch there, and yeah, what is going on there?
I think it's tragic. I haven't seen an impact on the industry, at least among my clients. We're still writing Terraform. The only impact that I've seen is GitLab removing support for Terraform from the pipeline templates that they provide. You now need to write your own pipeline. And yesterday we were talking about someone from Red Hat, and they also need to work on vendors who integrated Terraform into their code need to change now, but usual customers who just need to manage their infra, I haven't seen an impact. If someone has, please chip in. I think there was a question behind.
So first of all, thanks for the talk. You talked about easy to consume and understandable documentation.
Yeah.
So we have a lot of argumentation going around on which level that actually should be, because you mentioned people that consume the modules don't necessarily understand Terraform and are not profound enough to actually write Terraform.
Yeah.
And it sometimes feels like trying to teach a 4-year-old, if you know what I mean. Mm-hmm. So on which level do you actually start your documentation? So is it a step-by-step guide for service X, or do you work with videos? Do you work with pages? Because from my personal experience, you write documentation. In your point of view, it's easy to understand, mm-hmm. right? But people do not understand it, do not read it, do not care whatchamacallit. So
yeah, all of that will be true, whatever you do. You adapt to, you cater to what you know your consumers do. Like the last project that I did, the client had never worked with Terraform, so the README of the root README of the repo had step-by-step guides how to plan Terraform locally, what's where. In a general case, it's like a root README in the main repo with all of the Terraform, with examples. Generally, how to run Terraform and how to generate docs. Then every module has examples of how to instantiate it in different configurations. So like the usability. There is something called Terraform docs that can help you generate the docs for the inputs, outputs, modules, whatever. So that's nice. And then in the environments, that depends on who is the consumer. If I'm giving it out to developers who have no idea, I will be very specific about each available resource, make points around what's important. For example, in AWS, data is not encrypted. So one big point would be please encrypt your data. Don't forget to do that. Otherwise, if it's for the platform team only, just general, if you need to modify something, modify the TFRs. Videos is a really good thing, actually. I like doing, recording a flow of, I need to change something, here's how I change it, here's how I plan it, or the whole flow completely until it's deployed and then upload it somewhere. Because for a lot of people, watching videos is easier to consume than the docs. But then people will not read the docs. You can't do anything with that. You can read the docs, okay. Yeah.
Any more questions? Okay, then thank you so much, Natalie.
Thank you. Selfie. Yay!
And we've got yet another amazing piece of artwork for you from our artist.
Be documented. Oh my God, thank you. The artist and the art. Thank you so much.
Perfect. Thank you. All right, for all of you, we will now have lunch until 1:45. At 1:45, For those of you who have been to Swiss Cloud Native Day, you know that we have this tradition of having what we call a special talk. So a talk that is not based in IT necessarily, that is not based necessarily in the cloud native world. And this year, I'm very happy to have Dr. Sabina Raducan here from the University of Bern. She's a researcher in planetary science, working with ESA and NASA, and she's going to tell us about her experience there. So please be back here on time at 1:45 to hear her talk.